Hello everyone, and thanks very much for the introduction. It's really great to see you all, and it's such an honor to be here. Thanks very much for having me today. And my name is Yosuke Kaneko, and most of my career has been at the Japanese Space Agency at JAXA, working on space exploration programs. But I also lead a U.S. nonprofit organization, which is called the IPNSIG, where we promote the work of the Interplanetary Internet. My talk today is to give you a brief introduction of who we are, what's IPNSIG, and we'll also talk about the momentum that's building up toward lunar communication, and also some of the challenges ahead in deep space networking. And I will also try to give you an outline of some of the opportunities out there if you might be interested in getting involved in all the work of the Interplanetary Internet. The IPNSIG is a U.S. nonprofit. We were founded in 1998 by Vint Cerf, who is a real legend, known as one of the fathers of the Internet. He was one of the co-inventors of the TCP/IP protocol, which is really the engines of our Internet today. I actually assumed president in 2020, and ever since then, we've been working with more than 1,000 members today to facilitate the evolution and development of the interplanetary network. And in terms of membership, we really do have a pretty good global distribution, and our members would include Dr. Scott Pace, who was the former executive secretary of the National Space Council, and many engineers from the space agencies like NASA and ESA, and also JAXA, and from the private sectors, and also from the academia as well. Speaking of our vision, we really want to get to the point where we have a common network infrastructure starting from the moon. Our space communication is kind of conventionally done in a point-to-point manner. You would have a spacecraft flying around, and there's a ground station that's talking to that vehicle. And that's how we operate today. But I want you to imagine that if we were to stay on the moon and do all sorts of things like science and exploration, building a lunar infrastructure, and do commercial businesses on the moon, we will need to change our mindsets from a point-to-point regime to a more kind of like a network-driven architecture. And it's really important that we make this interplanetary network as a common structure, because in the end, it all becomes a benefit for humanity. And things are starting to sell off. It's no longer a fantasy anymore, and people are getting really serious about setting up a lunar comm infrastructure. NASA has a program called the LUNANET, which is the Lunar Internet, and the European Space Agency has the Moonlight program. Both of them have plans to provide communications and navigation services for users on and around the moon. So navigation is like a GPS system around the moon, and it's important that you know where you are, right? You don't want to get lost in the moon. So having a common nav infrastructure becomes really, really important for humans and robots to work on the moon. And these things are really in progress as we speak. And there are lots of companies that are interested in joining the LUNANET effort. And this is a list I created 2 years ago, which are the companies who participated in a workshop of LUNANET. And I really won't be surprised if the list had doubled or tripled by now, because the interest is really, really growing at this time. And for example, from the industry, the telco companies like KDDI and Nokia is planning to deploy a cellular 4G network on the lunar surface. And JAXA is also assessing the lunar comm and navigation architecture, and also promoting a lot of research on optical communications, like high power antennas or high power amplifiers, and modulation technology, and so on and so forth. And China also has plans to establish a Earth to Moon link, and they also have plans to send satellites around the moon to provide comm coverage of the entire moon sphere. And this is the interplanetary internet, which is a concept that Vint Cerf and I am promoting at the IPNSIG. I would say this picture is kind of an end state in the next 30 years or so, where different types of networks, the space agencies networks, the private sector's networks, and academic networks, they all join together to create a single network backbone that connects the Earth assets and the Moon assets and the Mars assets. And it's really IPNSIG's vision to work toward a common network infrastructure like the internet, because we already know how powerful it could be to have a common infrastructure, even in space. So this is a kind of a personal reflection I sometimes use. So what is about to happen in space networking is kind of analogous to the old days of the internet. So back in 1983, the ARPANET and SATNet and the PRNet, which were all different types of networks, but they all joined together using TCP/IP, which really gave birth to the operational internet. So to me, what is about to happen and what we are about to witness in space is very similar to this, where many types of different networks provided by different actors start interconnecting with each other. But there are, lots of deep space challenges that you need to deal with, like natural disruptions, like solar flares or cosmic radiation. And the other problem you need to deal with is astronomical distances and planetary motion. So whether you like it or not, the speed of light is too slow. Round trip times between Earth and Mars could be as long as 40 minutes. So TCP/IP isn't your friend here. It doesn't work very well in these highly delayed environments. There's also this planetary motion, or sometimes we call this orbital mechanics, where planets move around, and we haven't figured out a way to stop that. So if a spacecraft would go behind a planet, connections with their spacecraft could easily be disrupted. And these things do not occur in our terrestrial environment, right? And there are several work being done at the communication protocol level to compensate with these challenges. One of them is called the DTN, or the Bundle Protocol, which is to deal with these high delays and disruptive environments. And a lot of work is being done at the IETF, which is the Internet Engineering Task Force, and also at the CCSDS, which is the Consultative Committee on Space Data Systems, where space agencies meet together to discuss future protocol standards. So I want to show you how this actually works. So I created a simple manga. So let's see what happens if we were to use TCP/IP for deep space communications. So let's say that a source on Earth would be sending data to a destination on Mars. So when the data is sent, you would typically get an acknowledgement saying that, yes, I have received the data. But when a link would go down for some reason, you could be hit by debris or whatever, but whatever reason it is, if the link goes down, you would obviously lose a lot of data. And then when the link comes back up again, what happens is in TCP/IP, you would need to start your data transfer all over again back from Earth. So this doesn't work very well when we're talking about communications at interplanetary distances. So in DTN, in the same scenario, you would be sending data to your adjacent node, and that node will make a copy of that received data to its storage. And then the same process kind of repeats until it reaches its destination. So this is often called the store and forward approach. So if you would encounter a same scenario where your link is broken and the link comes back again, you don't have to start all over again from the source, because the node in the middle already has your data and can be used to retransmit. So that's how DTN works. And that's why it's called the delay and disruption tolerant networking. And NASA and JAXA and ESA and also CARI and of course us, IPNSIG, is also doing a lot of R&D on this technology today. And here's another interesting topic. So we have the internet today. So will there be a moon internet? So since the internet technology really matured so much on this planet, why not use it on the moon? These are real questions that are being raised amongst the space agencies and the private sectors, as there are several plans to deploy Wi-Fi and 4G and 5G on the lunar surface. But there are lots of things that needs to be sorted out. For instance, does it connect with the Earth internet? Or are we using IPv6 address space? Or will there be any autonomous systems on the moon? Or how does the routing work? Are we using BGP like on Earth? Or what about web browsing from the moon? Are we doing YouTube or TikTok from the moon? So there are tons of questions that we might need to figure out, which are really important questions to ask that really drives the overall architecture of LunarCom. So I spoke a lot about interplanetary internet. So actually there are several opportunities to get involved in the interplanetary internet. Well, first and foremost, we encourage you to come and join us at IPNSIG. We offer a program called the IPNSIG Academy, where we provide webinars on DTN, and you'll be able to hear a lot from the space agencies and the various stakeholders of the interplanetary internet. For example, we had Doreen Bogdan-Martin, who's the Secretary General at ITU, to one of our webinars last year. And if you come and visit our website, there's a whole bunch of archives of our past webinar talks as well. We also have projects to demonstrate DTN in terrestrial and also in space environments. One of the interesting projects we have is to use DTN to track reindeers in Sweden. So, reindeers move around, so DTN is actually a pretty good fit to track these reindeers. So it's basically used in the husbandry industry as well. And there are lots of more exciting projects that are underway. So if you want to get engaged, just scan the QR code at the bottom of the page. And later this year, we are planning to host a virtual workshop where we plan to show how to set up DTN on a Raspberry Pi and how to get started. So please stay tuned on that. And I think these opportunities can contribute to develop a UNISEC CubeSat in the future with DTN capabilities. And we would also be very happy to deliver webinars like this at a future UNISEC event if that would help the process as well. And just a few more things. There are other opportunities as well. One would be to engage with WIDE. WIDE is a huge internet research community in Japan led by Dr. Jun Murai, who is known as the fathers of the internet in Japan. And WIDE has lots of experts from the telco companies, the internet service providers, tons of researchers and students from Tokyo University and also Keio University. And they're really working on future internet technologies. And from last year, WIDE actually started to host a space networking working group in collaboration with IPNSIG. And we've started to implement DTN and all sorts of things. So WIDE is another venue to get engaged. And we also have IETF, which is the Internet Engineering Task Force. And this is really where the internet standards are being developed. It's an open forum, and anyone can sign up if you're passionate about working on future standardization of internet protocols. And the fantastic part is that they have two working groups that are working on space networking, the delay tolerant networking, which is also open to anyone. So if you might be interested, you can go ahead and sign yourself up there. And we'll make sure the charts go up in the UNISEC homepage so you don't have to take notes right now. And actually, that brings me to my last chart. So I just want to wrap up by saying that we are at a very exciting moment in space exploration, and the interplanetary internet is really the enabler to push humans back on the moon and even beyond. So let's do great things together. Thanks very much.